All right, what do we think? Anybody think they know what that's going to go to? So as b behaves more and more like pi over 2, so as b basically becomes a pi over 2, all right, because that's our limit. What functional value does the tangent approach as the x values get closer and closer to pi over 2? And the easiest way, I think, to answer this is this graph. Good. So this guy overall then should be taking off towards a positive infinity. The black graph is our tangent graph. As we get closer and closer and closer to pi over 2, that happens to be its asymptote. So the black tangent graph is taking off towards a positive infinity. So this is one that would diverge. When you write the word diverges, make sure you just have the work that justifies that. And in this case, we're showing that this function went to infinity. That's our justification, and then that's ultimately our final answer. All right. Now, go to the next page. You're going to see the quiz review. And there's some on here that you definitely want to see. These are now kind of up in the ante a little bit, where all the problems yesterday, you can look at those and you can do your antiderivative right away. It's kind of the order in which we did these for the year, where we first started with functions like 1 over x plus e to the x. We know how to do those antiderivatives. Eventually, you started getting ones where we can't just look at them and do them. That was use substitution. So if you go to number 1, this is kind of both. First, let's talk about what makes this the problem. It's got to be the 1. All right, so that 1 is going to become my b, and I'm going to calculate the limit. Since 1 makes it undefined, we just want to figure out what happens as we get really, really, really close to 1, since it can't actually equal 1. Technically, this is use substitution. You don't necessarily need to write this. You can if you want. I'm going to erase it here in a minute. The derivative, you use 1 minus x, the derivative is going to give you a negative 1 dx. We don't have to do use substitution if your derivative is a 1. But if it's a negative 1, we technically do because of that extra negative. This is not a negative 1, it's a positive 1. So understand how we'd have to divide that over to make it a negative. What we really want to kind of understand, I think the best parallel to this is these partial fraction problems that we did, where remember how sometimes we ended up with like 1 over x minus 6 plus 1 over 2x minus a 5, and we did those antiderivatives. Both of those give us natural logs. But remember how this natural log of 2x minus a 5, if we let u equal a 2x minus a 5, the derivative gives us an extra 2. Remember how we have to divide that over? That's really all we need to do with this one as well. This is definitely, as we go to do this antiderivative, that's definitely going to give you a natural log because the exponent of x has a degree of 1. But since the inside has a derivative of a negative 1 and R1 is a positive 1, we would need to divide that by the negative 1 coefficient of x and then evaluate that from 0 to b. All right. Then plug in your upper limit, plug in your lower limit. So we're going to get a negative natural log of 1 minus b minus the negative natural log of 1 minus, what is that, even a 0? This becomes a plus sign. This again becomes something nice. This is really just the inside of this becomes a 1, 1 minus 0. The natural log of 1 is 0. So that again takes us to this problem right here. What is the limit of this function as our b gets really, really close to a 1? So what we have to understand, and you want to understand this as much as anything we've done this year to use this, the graph of the natural log. So here's what the natural log graph looks like. Because that's the function that we're dealing with in this problem, right? So what we want to figure out is as your b gets really, really close to a 1. So think about how this would play out order of operations wise. If b gets closer and closer to a 1, then wouldn't the inside of this composite, the composite itself, wouldn't that then be behaving more and more overall like a 0 eventually? So what we're really looking for now is what happens to my natural log curve as we approach the x value of 0. That is why we want to understand what these graphs look like. So as the natural log curve gets closer and closer and closer to this x value of 0, would we all agree that that is ticking off towards a negative infinity? Okay, so because of that, since this overall takes off towards a negative infinity with this negative in front of it, that's going to diverge because overall that negative ln is going to have a value of a positive infinity. So this one would diverge. Okay. So the ln curve plays a pretty big role here. If we ever go towards infinity, it's also going to diverge because the natural log curve increases forever, even though it does it really slowly. Okay, so that's number one. Each one of these first three are pretty challenging. There's some tough stuff here. All right, so now number two. Easy to identify what the problem is. Here's the biggest issue with these, to be honest. Normally when I do give this quiz, sometimes it's a pretty bad quiz, and the biggest issue is doing the antiderivative. People look at this and they're not sure how to do the antiderivative. Same here. How do we take the antiderivative of this? This is really easy to diagnose that the infinity is our problem, so we're going to throw the b up there. But then the question is, how do we do the antiderivative of this? And that's where people start getting tripped up, because now every derivative or antiderivative type that we've done throughout the year is in play. There are no more methods of integration that we're going to use this year. We've got to be able to look at this and know how to handle this. So when we look at this, our first option is, can I just look at it and know the antiderivative? And the answer would be no. There's no power rule. There's no inverse trig function. We can't do it. Your second option with antiderivatives that we did during the year was u substitution. Well, if you let u be x squared minus an x, this 2x minus 1 doesn't do us any good, so that doesn't work. So we now have these new methods in this chapter. So not only is this the new improper integral idea, what this also is, so over here, remember how we did what we called partial fractions, where if I were to factor this guy here, doesn't that become x minus a 1? Well, let's factor it first. Let's not jump too many steps. X times x minus a 1. And then the partial fractions method is I'm going to do a over one of those factors and then b over the other. That's then what we want to evaluate. So when we go down here now to evaluate this, let me actually rewrite it down here. What we're really calculating the limit of as b goes to infinity is the a over x plus the b over the x minus a 1. So it's really now combining two of these new things from this chapter. This is our system. I think we're probably pretty good at this. Most people handle this pretty well. So if we want to make a common denominator here, our numerator on the left is a 3. Over here, our common denominator of x minus a 1. We do a times x minus a 1. And then b times x. Give myself enough room there. Sorry for you guys inside. So if I have that, what we do is we have a plus b. That's going to be the coefficient of x. And then I would just write this as plus a negative a. The coefficient of x has to be a plus b. Notice how there is no coefficient of x on the left-hand side. So that means a plus b would have to be a 0. But then the negative a, this works out nicely, that has to be equal to 3. So we quickly get a to be a negative 3. Since we know a plus b from this part right here equals 0, then we know b has to be a positive 3. When we go to set this up, do me a favor as we do this, just because it'll work out a little bit nicer. Put this first. So since the b had the positive value, do the 3 over x minus 1 first. And then we have the negative 3, so we'll then do minus 3 over x. Those are both nice antiderivatives, I would hope, so we can go through with that next step. This would be 3, the natural log of an x minus a 1, minus a 3, the natural log of the absolute value of x from 2 to b. And then here's where you want to be really, really careful. It's why I give you one of these, so we can talk about one of these before you see it on an assignment, before you see it on a quiz or a test or whatever. Before we really evaluate this and try to substitute these in, we always want to deal with natural logs in their most simplified form. So it goes back to, remember how if we ever subtracted natural logs, we can write them as 1 natural log if we divide their composites. So they both have a coefficient of 3, so we'd still have the 3. And then now I would take x minus a 1 and divide that by the composite in that second fraction, which is x. If you don't do that, you're probably going to get led down a path that gives you the wrong answer. We always want to deal with the most simplified version of our natural logs. Go ahead and plug. So you're going to have 3, the natural log of b minus a 1 over b, minus 3, the natural log of 2 minus 1 over 2. This is the nice one. So this is really just 3 times the natural log of 1/2. Once again, because this is now the next hardest part, say what you think this does. So calculate the limit as b goes to infinity for that expression.
I don't think it's 0.
You don't think it's 0? I don't know. I didn't say it's 0. What do you think it is, Ethan?
Well, I was like, I'm basically thinking that 3 natural log of, and both would be either infinity. So like 3 times natural log of 1, which is 3. Okay, so it is 0.
So now you agree it's 0?
Yeah, I did.
Okay. Let me set this problem up here. So direct your attention to this guy. So first week of school, we dealt with limits as x goes to infinity. And we talked about where the bigger degree is at. That's what we look at to determine what happens for our limits. These degrees are the same. So when the degrees are the same, we said their limits are their coefficients. So coefficient of 1 here, coefficient of 1 here, that has a limit of 1 over 1. If we look at the problem you are dealing with, handle it in order of operations, this is what we want to deal with first, because that's the innermost composite of this function. So as b goes to infinity, isn't this here, the combination of these two, isn't that really just this problem over here? Yeah, so what's going to happen is this overall, the composite of that natural log is going to behave more and more like a 1. And as that becomes a 1, what we're then really dealing with is the natural log of a 1. And the natural log of a 1 was ultimately what, Ethan, as you finally figured? Yeah, is 0. So that has a limit of 0. Because of that, we would say that this one converges. If it was open-ended, if this is a free response question, absolutely leave this. So it converges to a negative 3L and a 1/2. Guarantee you, though, if it was a multiple choice question, I'm definitely writing this as a positive natural log of 8. Remember, always our multiple choice are going to be the most simplified version of an answer. We get this from taking the negative. We can make that the power of a 1/2. So that becomes a 2, the reciprocal of 1/2. Take the 3, make it the power of the 2, and then that's going to be the natural log of 8. All right. I like that problem a lot. There's a lot going on there. You need to know it's an improper integral. You need to be able to do partial fractions. You've got to be able to evaluate the integral, find the limit. Really good stuff going on right there that we need to keep straight from all different parts of the year. All right, we good with all that? Does it make sense, hopefully? The next one is similar. Also another handful. You got to really just know elements of a little bit of everything we've done throughout this year to be able to handle this. So when we look at this function, obviously the infinity is going to be your problem. So we're going to set this up as limit as b goes towards infinity from 0 to b, and then we're going to deal with x e to a negative x squared. The first thing that usually people encounter is how do we do the antiderivative of this? So if we go through our options again, first option is this one I can just look at and say the antiderivative of? The answer would be no. If you look at number 4, we should be able to do the antiderivative of this very quickly, x to the negative 1 over negative 1. Well, 3 is not that type of a question. So the second way that we did any sort of an integral or antiderivative was with u substitution. So that would be your next option. So you'd say, all right, is there any value that I could let u equal so that the derivative would also help out and get rid of some of the things that we need to get rid of? This one, hopefully, we're not too far removed from u substitution to say, yes, this is something that we could use. Because if we let u be a negative x squared, the derivative of that is a negative 2x and a dx. We needed the x and the dx. We have it. We just don't want the negative 2. So we're going to divide that over and create the x dx that we still would have had in this problem. When we now go to rewrite our integral, you're going to have limit as b goes to infinity. We now have e to the u. And then this x and the dx that we needed to get rid of, we have here. What that's equivalent to is a negative 1/2 du. Then what we have to remember, and you have to do this because they're going to look for this work, your limits need to change right now, right? We just went from x's to u's. So your limits need to change from x's to u's also. Remember how we did that right here with this conversion, this statement of equality between u's and x's. So if you took the lower limit of 0 and plug it in, that actually stays a 0. Your upper limit, since this is an improper integral, was a b. So when you plug your b in, you would get u to equal kind of a weird looking limit, but negative b squared. It has to look like that. If you don't write it like that, you're going to have to do something like this very, very soon. If it doesn't look like that, you have to have the u limits, and you have to show that it's an improper integral with the limit as b goes to infinity. If you don't, then it's going to be really cheap points that you would lose. All right, so then from there, you're going to do your antiderivative. I'm going to pull the negative 1/2 all the way out in front so we don't have to deal with it because it just makes it messier. So the antiderivative of e is just itself, and we're going to go from 0 to a negative b squared. Plug in the upper limit, lower limit, subtract them. So you're going to do e to the negative b squared minus e to the 0. So we're going to have this 1/2 multiplied by whatever happens in here. E to the 0 is easy. That's a 1. And then here we are again. Oops. Evaluate this limit. What's going to happen to this problem as our b goes to infinity? At least think it. Write it down in your head if you're afraid to write it down on your paper. And then see when we do it if it's the same thought that you currently have. If it's infinity, it diverges. It's certainly a valid option with these. If it's a value, then we're going to converge to something. Who is that, Alex? I wasn't looking. Okay. It's an educated guess, though, right, Alex? It's not just a guess. It's an educated guess. Okay, what's your educated guess, Alex? The overall answer? Or what's this converge to, then? If you're saying it converges to 1/2, you're saying this converges to something. So Alex says this is 0. Do we agree with Alex? You're getting some affirmatives in here. Kevin's nodding yes. All right. Well, walk us through this, Alex. Why do you think it's 0?
So as you go to negative infinity, that just gets smaller and smaller and smaller until you have 0.
So he's saying, basically, don't we have e to like a negative? Let me just throw as many zeros as I can in here because it's going to infinity, right? You're not squaring the negative first, right? We're squaring the b, so the negative doesn't get squared. So wouldn't e to the negative 1 million, whatever that is, what is that? It's billion, negative 1 billion. Isn't that just e over some huge number, or 1 over some huge number? Wouldn't that then have to be going to 0? To be a little bit clearer, let me do this real quick. This is how I would usually show it. Take this guy right away. Can't we put that into our denominator? And then now it's more clear. Your numerator is always a 1. Your denominator is going to be getting bigger and bigger and bigger and bigger and bigger and bigger and bigger. So this guy, correct, takes off towards 0. So we have that negative 1/2 times 0 minus a 1. So like Alex said, this converges to 1/2. Okay. That's some deep stuff. That, again, requires you to know a lot of things. Limits from the beginning of the year, use substitution, the improper integrals. It's, like I said, calc just kind of builds on itself more and more and more. Everything we use at the beginning of the year, we continue to use. All right, good. All right, where are we at? This one. Yeah. We should probably do it. We got some time. I don't know if we'll go all the way through it. Just remember, the reason I put this one on here when we normally give a quiz to make sure we understand. Sometimes you have to set up different integrals. 0 is your problem here. Since 0 is the problem, that's what you're going to make your variable. So we're going to put b here and then b here. And then this is one we can do the antiderivative very quickly and easily. No weird use substitution, partial fractions, any of that. What we're hoping for, we said, is that this just diverges, and then we don't have to worry about the other one. So do your antiderivative. Although I'm being lazy. We want to figure out what happens as we approach 0 from the left with this. And we would get negative 1 over b minus a negative 1 over negative 1. Talked about this yesterday. Actually, I feel like we did something very similar yesterday. Now I look at this, because Zach gave me this answer. This is going to give us a minus a 1. And we talked about what happens to this value here if our 0 is a negative 0.1, negative 0.01, negative 0.001. This answer should take off towards an infinity. And then because of that, this one would diverge. You don't have to worry about the second one. Everything is all good. Okay.